Hello. So today we're doing another problem once again that is not on Leetcode, I don't think. Um, Still level ordered traversal or like breadth first search. Um, Given a binary tree, connect each node with its level order successor. The last node of each level should point to a null. In this case, since we're doing it in Python, it's called none node. Yeah, so the only difference is our tree nodes now have a self.next, and we want to be assigning these to a node. Basically, we just want it to sort of function like a linked list while also being a binary tree. You can ignore this. This is just used to print our statements, and yeah. So without further ado, we will get started on the problem. If root is none, then we can just return. We actually don't need to return anything because if you look, because we're just modifying the actually I don't think we need to return anything because we're modifying the tree, but in the case where we do need to return something, we can always just add return root or return none here, and at the very bottom we can just return root. But I don't think we need a return. I guess we'll see at the very end. And so we'll do the typical things that we do for breadth first search, which is initializing dequeue, which is why we have it imported here. And yeah, so after we initialize queue, we can do queue dot append root, because we now know that root is not none, because otherwise we would have left the function already. And so now we'll do our iterations of the queue. So while the length of the queue is not 0, which means we do have nodes, which means we do have to treat the we have to modify the self.next values of more nodes. We need to obviously keep going. So here we're going to get a length is equal to what is it? Oh, length of queue. Sorry, blinked out for a little bit. And here we will start modifying the self.next, or the node.next of the nodes. So for I in range of length, which means for the number of nodes on this level, we want to be doing this like modification, right? So we're gonna have node equals q.pop left, pop left, and then if I is equal to length minus 1, because the way this for loop works, right? You won't actually hit the length. The last one you'll ever hit is length minus 1. And if we're on the last node, we want it to point to none, right? Because there's nothing else in the same level. So we'll just do node.next is equal to none. Oh, whoops. And then else, basically, if you're not on the basically, if you're not on the last one, node.next is equal to q0. Yeah, so basically you look at the next thing, and if you're not at the last node on this level, you know there is at least one node following the node that you're currently looking at that is also on the same level. So you can do node.next is equal to q sub 0. And then here you'll just do the basic if node.left. I actually figured out by looking at this, you can actually just do if not root, which is this is equal to root is none. If you do this, this is equal to root is not root, node.left is not none. So you can actually, you know, make the code a lot shorter. You can do q.append node.left, and then if node.right, which once again is equal to node.right is not none, q.append node.right. And you know, that just, we've gone through every node in our binary tree, and for every level we've handled it so that the last one is pointing to none, otherwise we're pointing to the next one, and we've added every node in. So here we can just return out of this function, and then we can print it. So if we did things correctly and we run this, epoll selectors, oh, I guess that's from my typo earlier. Let me just delete that so we have a fresh terminal. And yeah, so our root is 12, and if you look through this code, so next level root will start at the 12 because that's what we're calling it on, root, right? So start at this, the current becomes equal to 12, and this becomes none, right? And so once at 12, at current, we print 12, which is here, with a space, and then the end of this this level, you will end up having well, just no characters, and then so we'll keep going. If there's no next level root, so it's none, which is none right now, right? We want to look at left, if something's at left, and then the left here is 7, so now next level root is at the value of 7, and then since you already have something, you don't need that. Current equals current.next, but there's no .next, so it's none. So while current, so now current is equal to none, right? So then we'll end up printing, which is the 12 with a space, and then the empty character, and then 7. So now you just keep going on. You make this none, and then you keep going 7, and then 1, which is the next, and then another end of the level, and then so at 7, so at 7 left is 9, so then the next level of root is 9, right? And then we go 9, 10, 5, 9, 10, 5, and that's what we expect, right? So we look, so that, you know, we've done the question properly. So now we're back to, you know, our code. Guess we don't need that much space in between. But yeah, so that is the connect level order siblings question. Thank you for watching.